Chapter 8, Lesson 4, Use Scientific Notation. So scientific notation is a form that's used when you have really big or really small numbers a lot of times. So the key thing to understand is that there's two parts to it. The first part is always going to be a number that is greater than or equal to 1 and less than 10. So it could be any number. It could be 3.2, could be 5.7, could be 9.9. It cannot be 10.2. It cannot be 0.5. It has to be between 1, it could be 1, but it has to be 1 or greater and less than 10 in order for it to work. And then that's going to be times something to the 10th power. And so the easiest way of looking at this is to look at examples here. So I'm going to look, these ones here are written in standard form, and the ones up at the top are these ones here are written in scientific notations. The ones at the top here are written in standard form. So the way it works is it's just really counting and moving over decimal points. So if you look here, the number that's here, I'm going to rewrite this out just to make sure it's clear. Okay, so that's that first number right here, and that's 397 million. So the decimal point, if it's not listed, is always at the end. And what you're trying to do is you're trying to make it so that the decimal point will end up here, because that's where you're going to get the number that for the number, the first part is going to be between 1 and 10. And I'll show you what I mean in terms of that. So I'm going to move the decimal point over 1, 2, 3, 4, 5, 6, 7, 8 spaces. So I move it over to 8 spaces, and then I'm going to have 3.97. Since I moved the decimal point over 8 spaces, I have to put it times 10 to the 8th power. So let's try that again, because I think it'll be a little bit clearer if we do it with this problem as well. So for that one there, it's 2,750,000. Okay, so the decimal point in this case is going to be right here. So I go 1, 2, 3, 4, 5, 6. So our number is going to be 2.75. That's the number that's 1 or greater and less than 10. And then this is going to be times 10 to the, how many spaces do we move it over? We move it over 1, 2, 3, 4, 5, 6 spaces times 10 to the 6th power. Now this works the same when you're dealing with negative exponents as well. So in this case here, I'm going to rewrite this problem out here. 0, 0, 0, 7, 1, 2. I can write that out in scientific notation terms, but in this case here, I'm going to have to move the decimal point over in the opposite direction. So it's 1, 2, 3, 4. And now I've got that 7.12 part times 10, but in this case here, it's going to be to the negative 4th power, because I'm moving the decimal point to the right. If I'm moving the decimal point to the left, it's a positive number, and if I'm moving it to the right, that's a negative number. I like to think about it, if I'm working with really small numbers, it's going to be a negative exponent. If I'm working with really big numbers, it's going to be a positive exponent in terms of scientific notation. So for this one here, it's going to be over 1, 2, 3, and then it's going to be 4.86 times 10 to the negative 3. So for these here, when you write number in standard form, all you got to do is you're going to move the decimal point over, depending the direction on whether it's positive or negative. So here, 3.02 times 10 to the 4th is going to be, I rewrite it out as 3.02, and then I just add a bunch of zeros here, because I'm going to move the decimal point over. So it's going to be 4 spaces I'm moving over. 1, 2, 3, 4. Now I don't need those anymore, so I'm going to get rid of them. So my final answer is going to be 30,200. And that's the final answer. For this one here, it's going to be 1.012 times 10 to the 3rd. And I can move the decimal point 3 spaces, so 1, 2, 3. So the answer is going to be 1012. For these ones here, you're moving the decimal point the opposite direction. So for this bottom one, 3.7 times 10 to the negative fifth power. That's the same as I'm going to put a bunch of zeros in front of the 3 because I need to move it to the left now instead of to the right. So I need to move over 1, 2, 3, 4, 5 spaces over. And that's actually where it's going to end up being. So it's going to be 0.00037. That's the number written in standard form. Ooh, I forgot one more zero. It's important to count your zeros to double check that. So it should be 0.00037. For this one right here, it's going to be 9.131. And I have to move the decimal point over 3 spaces to the left. So it's got to be 1. And if you want to add zeros when you need to, you can. 1, 2, 3. So my answer is going to be 0.009131. That's it written in standard form. So let's look at this. If you have a problem where you're combining two numbers of scientific notation, what you have to do is you have to divide them up into two separate problems. What you're doing is you're just changing the multiplication using the commutative and associative properties. So what I'm going to do is I'm going to multiply the numbers together, the 3.2 and 4.7 together, and then I'm going to multiply 10 to the fourth power times 10 to the third power. And that's going to give me 15.04 times 10 to the seventh power. Now, if I'm supposed to leave it in scientific notation, I can't leave it that way. I have to actually go ahead and move the decimal point over one more space. So I'm going to end up with 10 to the eighth power because I moved it over one more space. It's going to be 1.504. Let's look at least one problem like this. So if this is the problem we're looking at, it's got to be 9.1 times 2.3, whatever that is. And then that's going to be 10 to the seventh times 10 to the negative 8, I believe is what that says. And when you do that, you're going to end up with 10 to the negative 1, and I'll do the math here quickly. So it's going to be 20.93 is what that is part is going to be. Then this part is going to be simplified to 10 to the negative 1 power. So the problem is that I still have to move the decimal point over one space. So when I do that, it's going to be 2.093, this is kind of funky, times 10. Since I moved it over one space, it's going to be times 10 to the 0 power. You can actually do that in terms of scientific notation if you're asked to write something out like that. Technically, I don't know why you do that, because it's just actually this, because remember, any number to the 0 power is just 1. But if you're instructed to do it in scientific notation terms, that's the way you would do it. So the same thing's going to happen with these problems here. You're going to divide the 2.6 by 6.5, and then this 10 to the 6th power divided by 10 to the negative 2 power. So that's going to lead you to 10 to the 8th power, and then it's just going to be 2.6 divided by 6.5. So that's going to be equal to 0.4 times 10 to the 8th power. But I can't leave it like that. I've got to actually move it over one space. So it's going to be that way if I'm trying to put it in scientific notation. It's going to be 4.0 times 10 to the 7th power, because I had to move over one more of those. I had to use one of the 10s to move over the decimal place.